Well, welcome to a question today, and this is question 1. And no doubt you've read the question, so let's just get straight into it. We've got to label these forces onto our diagram. So we've got the wind blowing at G/2 going that way. We've got gravity force, mass times gravity. So that's 4 times G going downwards, and we get a tension force going upwards. Knowing those 3 forces is pretty key. Next part, calculate the value of T. So we need to look vertically and horizontally. So vertically, we've got, I'll just scroll down a bit now, give myself a bit of room. Vertically, we've got this 4G cranking down, and the only thing that's going to counterbalance it, because the wind is blowing sideways, the only thing that's going to counterbalance it is the component of the tension that I'm drawing up here in black. So that there, I'll just call that X for a tick, that is balancing the 4G. Because the plane's not moving upwards or downwards, so it's acting at some angle theta, who knows? There's my right angle. So I can say that cos of theta equals x on t, so x there equals t cos theta, and like I said, that's exactly balancing with the 4G going down. So this x going up equals the 4G going down. In other words, the t cos theta is equal to 4G. Okay, now let's look horizontally. We've got this G on 2 cranking out that way. Now once again, we've got our tension force cranking there, and I want to know, because it's the only thing horizontal, the gravity wasn't going, I want to know what that is, what that y is there, because that black vector y is exactly equal to the G/2 going the other way, so that everything's balanced, because the plane's not moving, it's just sitting there. Now before, when I did this one up here vertically, I called that theta. So if you like, if you want to put theta up in there, because they'll be equal to each other, alternate angles if you like, then I can work out what y, cos sine theta equals y over t. So y equals t sine theta. Now that y is equal to G/2 because they're balancing each other out horizontally. So t sine theta is equal to G/2. Now here's the kicker, I don't know what that angle is. I want to find what t is, so I need to eliminate theta. But you know, if you're looking at dividing, you might end up with sine on cos and still end up with tan theta. You'll still get a statement with tan theta in there. So what would be a good idea is to square both sides and add. So say I square this, I'll get t squared sine squared theta. And I square the other one, I'll get t squared cos squared theta. That's squaring both the left-hand sides and adding. So let's square both the right-hand sides and add. So I just took what was in those boxes there, squared and added. Now, why is that good? Because we know what sine squared theta plus cos squared theta is. Indeed, it's 1, isn't it? 16g squared plus g squared on 4. All right, we'll come up here with this. T squared times 1 for sine squared plus cos squared equals, that's 64g squared on 4 plus g squared on 4. So t squared is equal to 65g squared on 4. Now we want to know what t is, so we're going to square root, and we know that it's a positive like size force, right? So I'm not going to worry about the negative square root. So I'm just going to take the square root of 65g squared on 4. Now I just want to have a look at how they want me to present that answer. G on B root A, because this will be like root 65g on 2, if I do that. But I've got to present it the way they want it. So I need to write G root 65 on 2 technically. So I'll just swap those around and write G root 65 on 2. So that there in the cloud is what the final answer is. Thank you for listening to my answer to our question a day, number 1.